Hi, good afternoon, everyone. Today we'll divide into the fascinating world of PIC microcontrollers architecture. This topic is not only introduces the backbone of countless electronic applications, but also help us to understand the precision and the intelligence of modern-day embedded system. Are you ready to explore? Let's begin. So this is the architecture of big microcontroller. In the previous classes, we have discussed a lot on this. So it's like I'm going to cover the parts where we did discussed in the previous session. So first we'll go with analog to digital converters. So these converters along signals, it's like convert the analog signal into digital values, enabling the microcontroller to process the real world inputs. Timers and counters, four timers, including 8-bit and 8 bar 16-bit configurable ones, which are used for precise time delay and even counting. Then interrupt. It supports 20 internal and 3 external interrupts to prioritize the task, enhancing the multitasking capability. Then comes the serial communication. Transfer data one bit at a time over channels commonly used in USB, GPS, and Bluetooth system. Then coming to oscillator, it's like a crystal or RC oscillator generates precise timing signal for the microcontroller's operation. Analog to digital converter, these are like a translated in a microcontroller. They think about the thermometer. It reads the analog temperature, but if you want a digital reading on screen, we need a conversion. That's exactly what analog to digital converter they do. They turn analog voltage into a digital format that the microcontroller can process. What's amazing is how these converter bridges the gap between the analog real world and the digital logic of machines. Can you think of other example where such conversion might be necessary? Okay. Timers and counters are like the timekeepers of the microcontroller. Imagine planning a space mission. Every microsecond matters. These timers can operate in 8-bit or 16-bit modes. Depending upon precision needs, they can create precise time delay or count pulse in an operation. Let's say you have an automatic street light. Timers are what determine when to turn it on or off. Is that cool? Let's brainstorm. What else might such timers or counters be used? You just put your comments in the chat box. Here's something exciting. It's interrupts. Imagine you are listening to music on your phone and suddenly there's a call. What happens? The music passes and the call takes over. That interrupt is in action. The microcontroller supports 20 internal and 3 internal interrupt sources as we have discussed earlier. These interrupts can handle tasks like a serial communication, ADC and timer seamlessly. It's like the microcontroller has built-in ability to multitask. Pretty amazing, am I right? Now let's talk about serial communication. Method for transferring data one bit at a time. Picturing this, it's like you have a single lane bridge allowing one car to pass at a time. Serial communication works in a similar way. This method is widely used for reliable data transmission over the long distance. Devices like USB, GPS system, and even Bluetooth uses serial communication. Does anyone want to share an example where you have encountered this? Please put it in the chat box. Finally, we have an oscillator, the heartbeat of the microcontroller. These generate the timing signals that keep everything running smoothly. This big microcontroller uses external oscillator like crystal oscillator, which are highly precise. It's like having a maestro in an orchestra, ensuring all the instruments are perfectly synchronized. Have you ever wondered how clocks in your gadgets maintain the accuracy? That's the magic of an oscillator. To wrap it up, the microcontroller PIC is a powerful house with a versatile feature with like analog digital converter, timers, interrupts, serial communication, and oscillators. Understanding these concepts and components is essential for designing an efficient embedded system. I hope today's session gave you a glimpse of incredible potential of this microcontrollers have. If you have any questions or example to share, I'd love to hear them. Thank you. Let's keep exploring the amazing world of technology. Thank you.